Hello, I'm Stephen Cole, and welcome to the Answers Project podcast from CGTN Europe, where we try and find answers, or at least make sense of, some of the trickiest questions facing us in an increasingly complicated world. We've got access to some of the best brains on the planet to see if they can help shed light on some of the most pressing social, ethical, scientific, geopolitical, and philosophical quandaries. And I'm joined by Mhairi Beveridge, who's going to help me unravel this week's question. So Mhairi, what are we asking this week?
It's a big one. It's possibly the biggest question we've attempted so far in this podcast. We're asking, are we alone in the universe?
So basically, does extraterrestrial life exist beyond our planet? So we're going to end the series of podcasts with the easy one.
Yeah, and we're going to try and attempt it all in half an hour. You know, what could possibly go wrong? Now, obviously, this is an incredibly complex question, but when you think about it, it really boils down to two possibilities. Either we are alone or we aren't. And it was Arthur C. Clarke who famously said that both of those possibilities are equally as terrifying.
When we ask, are we alone, really what we're asking is, are there other living beings beyond Earth? Is that right, Mhairi?
Yes, we're effectively talking about aliens here. Now, how developed or intelligent these aliens are, or whether they'll ever successfully contact us, is a different matter entirely, which we will come to.
So, OK, let's start with what we do know.
Thanks to organisations like SETI, which stands for Search for Extraterrestrial Intelligence, and NASA, we have discovered quite a lot in the last 60-odd years. In 2009, NASA launched the Kepler Space Telescope with the aim of finding Earth-like planets that are the same distance from a sun-like star. And they're looking for these because they are the most likely to host life like ours. The results of this mission showed that there were as many as 40 billion Earth-sized planets in the habitable zone, which is often called the Goldilocks zone.
So not too hot, not too cold, I suppose.
Yes, exactly. It's got to be just right. So this means, Stephen, that there are billions of potentially Earth-like planets in the universe with the right conditions for life on them. So that's good news for the case of, yes, there is life in the universe. OK, that all sounds very promising, but I suppose the key question is, what do you mean by the, in inverted commas, right conditions for life? Well, I think the best person to go to on this is probably an award-winning astrophysicist, wouldn't you agree?
My name is Didier Queloz. I am professor of astrophysics at the University of Cambridge. My main occupation is to look for planets and other stars, first to find them and then to characterize them, trying to get what they are, what they look like, and eventually we are going to look for life on these planets.
Impressive as he sounded there, he managed to sell himself a bit short. Professor Queloz actually won the Nobel Prize for Physics in 2019 for the discovery of an enormous exoplanet alongside Michel Mayor. But coming back to your question about the right conditions for life, here's what Professor Queloz told me.
Well, the first one is life is nothing else than a chemistry process. So there is no magic, there's no something special about life. And if you push it a bit further, it's a chemistry process that is become its own master. As soon as you get life manages to make its own chemistry and to evolve. And that's what we're talking about. So I do think the chemistry are the same everywhere in the universe. And I do believe that if the right conditions are met, you create life.
What he's saying here is all the elements necessary for life as we know it here on Earth are present in the universe. So carbon, nitrogen, oxygen, silicon, sulfur, phosphorus, copper and iron, all of these elements aren't exclusive to Earth. So when we look inside meteors and asteroids in our own solar system, we find not only these elements, but we find them configured into like organic molecules and sugars and amino acids.
So if I've got this right, in other words, not only are there billions of Earth-like planets in the universe, they all have the right raw ingredients for life.
Yes, exactly. The raw ingredients are out there and the conditions are right on billions of planets. All the evidence so far says it's very likely there's life out there. OK, so let's imagine some life has formed on a distant planet. Can we reasonably assume or expect it to be like life as we know it? You mean like us? I mean, it's a good question, and it's one that's been at the heart of a lot of sci-fi films. I asked Professor Queloz how developed this kind of life might be. And he said developed isn't really the right word. It's more about that evolution.
The life mechanism is as well developed in the blue algae that in my body. There is no differences. So the concept of having a machinery which is alive, that is alive and evolving, didn't wait for us. Now, what is going on here is there is this evolution of life, and then you reaching a point in our case, in our species, where we are departing from our own places. So if you define as, could you have some kind of species that is able to reach a level that can travel to space as an evolution of life? That's a very open question at this point. The fact that we have not seen obvious trace of alien visiting us is a famous paradox that Enrico Fermi had clearly spelled out, must be for 60 years ago. He said, well, if they are alive somewhere, it should have evolved sooner or later. So they should have reached a technology such that they could travel. So where are they?
I want to stop Professor Queloz there because he's brought up a crucial part of the history of this question, which is the Fermi paradox. Have you heard of this before?
Well, I think so, but at the risk of stretching my limited knowledge of astrophysics, I think it's something to do with aliens.
Yeah, basically, the Fermi paradox is named after the Italian-American physicist that Professor Queloz mentioned there, Enrico Fermi. He was one of the first to outline this contradiction between the lack of evidence for extraterrestrial civilizations and the very high estimates for their probability, as we've discussed.
In other words, it's highly likely they are out there, but where are they?
Exactly. It was really hard to find anyone for this podcast who would tell me categorically that aliens don't exist. And yet we haven't found any evidence.
And science has to rely on evidence to make any claims?
Yes, exactly, hence the paradox. It's a real stumbling block when it comes to the search for extraterrestrial life. However, I did find someone who really shook up the space community in 2018 when he released a paper titled Dissolving the Fermi Paradox.
I'm Anders Sandberg, Senior Research Fellow at the Future of Humanity Institute at the University of Oxford. And my job is really to think about the big picture, the fate of humanity, where is the universe going, and what can we say about these very uncertain and weird questions?
So that's Anders Sandberg. He's one of the 3 authors of the paper Dissolving the Fermi Paradox. And in this paper, they reevaluate Enrico Fermi's theory in such a way that it makes it actually seem very likely that humanity is alone in the observable universe. They also took on the very famous Drake equation, which is a long formula that uses probability to estimate the number of active extraterrestrial civilizations in the Milky Way galaxy. And he explained the issues they found with these widely accepted arguments.
So we noticed that many people, when they reason about it, do something like this. There are many places in the universe and a lot of time where life and intelligence could emerge. Multiply that with some reasonable probability and you ought to get a lot of intelligent life, and something is weird. The problem there in that sentence was reasonable probability. Where does that come from? And people bring up the Drake equation, and then they put in numbers and admit they are guesses. And then they get a number out of it, which is also a guess, and they admit that too. But it seems to tell us something. The problem is they are doing it slightly wrong here. When I'm guessing at how many inhabitants there are in London, I should be giving a range instead of just saying a number and saying I'm kind of uncertain about this. And if you use ranges instead, you get a distribution of answers, and that's actually quite revealing.
So he's basically saying the Fermi paradox involves far too much guesswork.
That's right. He's saying, given the current knowledge, too many of the parameters are uncertain. And although we've learned a lot in the last 60 years, we are still very unsure about the probability of life and of intelligence.
I wonder if that's taking us back to square one. But I suppose it's worth mentioning, it's not just about life surviving, isn't it? It's about evolution, that key word. Life has to thrive for billions of years on a planet and evolve in order to get to a state that we would call intelligent. So I suppose, what if there was a catastrophic warming scenario like Venus or a catastrophic freezing scenario like on Mars?
Yeah, it's a very good point. And of course, once that life has evolved, thrived and become intelligent, it then needs to gain the ability to announce its presence to the universe. And here I'd like to go to the author of the Black Hole Survival Guide.
I'm Janna Levin, and I'm a professor of physics and astronomy at Barnard College and Columbia University in New York City.
She says that the likeliness that intelligent life will ever be technologically advanced enough to communicate with us is chronically unlikely.
There is this haunting feeling when you look out into the Milky Way that even if there is life out there somewhere, that the likelihood that it happens to overlap technologically with ours and is also simultaneously near enough to communicate with us, that starts to feel, I don't know, epically unlikely. And yet when we talk about searching for life, we're not really looking for other creatures like us at the same stage of evolution. If you think about how long human beings have been on the Earth, it's only been a few 100,000 years. And if you compare that to the dinosaurs, right, which roamed successfully for hundreds of millions of years, we're a bleep on our own planet. So you're asking for this alignment with the technologically sophisticated society. That's a tall demand. So a lot of what we're really trying to do when we're looking for life in the universe is have more modest ambitions. Just try to see if there's microscopic forms that are metabolizing, and maybe we'll see signatures of reprocessing materials, the way things, that's what we really in some vague sense mean by life. It eats things and it metabolizes things. And so that's kind of where the hope is, to look for signatures in the atmospheres of some kind of metabolic processes that we might consider to be life forms.
But we've been sending messages into space since the 1970s, haven't we? I believe it was 74 when the Arecibo message was sent out from Puerto Rico. And there have been dozens of attempts to send out radio signals into space. Some may have been received, we don't know, but won't some of them have been received eventually?
Yeah, I mean, there's no way of knowing whether or not they've already been received and whether or not a reply is already on its way back to us. But without even getting into how long those messages will take to travel across the universe, I mean, we're talking light years, it's just incredibly unlikely to be successful. I mean, how sophisticated is the radio? We don't even use the radio as a primary means of communication here on Earth anymore. It's just a bit vintage. So, you know, how likely is it that a sophisticated alien civilization is tuning their DAB radio too?
Extremely likely, in my book. You are such a millennial, Mhairi. I mean, radio audiences are on the uptick. Again.
I walked into that one.
You certainly did. And I'm sure we also sent a time capsule into space in the 70s. The Voyager records?
Yes, that was 1977, the Voyager Golden Records. And they were literally gold-plated records. And these had sounds and images which were supposed to show the diversity of life on Earth. I don't know if you've ever actually heard them, but I think they're absolutely terrifying. Can I play you a bit?
Hello from the children of planet Earth.
Üdvözletet küldünk magyar nyelven minden békét szerető lénynek a világegyetemen.
各位都好吧，我们都很想念你们，有空请到这儿来玩。
I think that's extremely frightening.
Isn't it?
And if we sent that message into space, I wouldn't reply.
No, I don't think I would
I'd
either.
turn my DAB radio off.
Well, it's actually as well, funnily enough, Carl Sagan's laugh at the end. Would you believe it?
Yeah, that's fantastic. Well, I did think it was interesting what Professor Levin said earlier about not necessarily searching for species like humans, or even a species that is at the same stage of evolution as humans. She's suggesting, I think, we should maybe not be looking for people in human form, but be looking for bacteria or microscopic forms in space. In other words, traces of life.
Yeah, she's effectively saying, let's lower our standards for the life forms that we're searching for. You know, less E.T. with a cute pair of eyes and a nose, and more like microbial jelly.
Yes, that's how I feel some mornings. That doesn't give us much hope, though, in terms of intelligent, again, in sort of inverted commas, life, does it? Mind you, there is not often a lot of evidence of intelligent life here on Earth. But speaking of ET, what about UFO sightings and identified flying objects? A lot of history there, a lot of coverage, a lot of suspicion. How much weight do they hold actually as evidence?
Well, I mean, last year there were nearly 4,700 global sightings of UFOs. I have to admit I'm a bit of a skeptic. Firstly, because the overwhelming majority of these sightings happen in America.
And over deserts, normally. All seems a bit of a coincidence?
Yeah, too much of a coincidence for me. So for some clarity on the validity of UFO sightings, I spoke to Professor Chris Impey. He's an astronomer and professor at the University of Arizona.
The evidence has continued to grow and the number of sightings continues to grow, and it's a worldwide phenomenon, apparently. But the evidence has never met the bar that scientists would place on such an extraordinary hypothesis of alien visitation. So there's a gold standard of evidence, and Carl Sagan put it as extraordinary claims require extraordinary evidence. And if you're going to say that aliens have traveled across the galaxy and visited the Earth, you need something a little more than one eyewitness account or some photographs or images.
He did also say that there is a fraction of the evidence that's actually quite compelling.
You know, most of it is easy to dismiss, and the conspiracy theories and the abduction reports, you know, really, they're almost amusing. But there's a little persistent residue of evidence that emerges from military sources and then gets declassified. For example, sightings of spacecraft, maybe not spacecraft, but aircraft moving in very unconventional or almost unphysical ways. So there's a little residue of evidence that's very provocative, and it has some validity because of the source. So I would keep an open mind as a scientist on the possibility that there's something that truly does need to be explained.
Yeah, I mean, I think, but my theory is a lot of them are secret weapons testing. But he's saying, and I think he's right, keep an open mind as long as the source, not necessarily Captain Kirk, is trusted.
Yes, exactly. I think the UFO argument is interesting because it sort of forces us to think about actually interacting or communicating with extraterrestrials. I asked Janna Levin, who we heard from earlier, whether she thought we'd ever meet other sentient forms of life.
I think it depends on what you mean when you say meet other life. Do I meet a bacterium? I mean, discover, yes. And I'm not at all presuming that we are the end of what is possible in terms of complex brains. I really hope we're not. But I do worry. I do have a little bit of the pessimist's dystopian fear that longevity doesn't come hand in hand with that kind of intellectual complexity. So maybe the longer lived species are simpler and again, less aggressive with their environments. An interesting thing to note also is if you look around the Earth at the signals we first sent out into space more than 70 years ago, intentionally, those signals in the 70, let's even call it just round up to 100 years, the distance light has had to travel in 100 years is nothing compared to the scale of the galaxy. The galaxy is over 100,000 light years across, and that's just our galaxy. So you're talking about having only gone in space 100 light years. Now, there are planets in that small region, but you've barely begun to communicate with your neighbors at that point. And so to really imagine a species that's lived long enough to send a signal that reaches the other side of the galaxy, that species would have been able to use technology, harness technology hundreds of thousands of years ago. And then you have to wait for the signal to come back.
So let's think about that phrase again. Longer lived species are less aggressive with their environments. Is, therefore, Professor Levin hinting at the destructiveness of humankind there?
Hinting, yes, but in fact, she sort of spelled it out for me. She said we are a blip on our planet compared to many other species, and she thinks we're likely to self-destruct.
I think there's something to be said for the fact that a species that emerges to begin to manipulate its environment to the extent that we have, so that we have made ourselves entirely dependent on that manipulation of our environment, may not be successful and that maybe species that evolved to that point are inherently destructive and aren't capable of prolonging their species' lives long enough to be able to communicate with each other and other civilizations.
Oh, how interesting. God, it makes me feel very stupid.
Well, I mean, imagine dolphins, if we weren't here, very happy, very successful species, has no intention to send messages out into space and isn't trying to receive any. So maybe those are the most successful kinds of animals that emerge on other planets as well.
Be more dolphin is the message.
Learn from the dolphins.
Dolphins or whales, we're only just beginning to try and interpret some of their signals, actually. But it is a chilling thought, the human race, and one that I sort of share to a certain extent. I have to say, although, as you know, I'm a cynic, the human race may become a victim of its own success.
Yeah, I would have to agree with you there. It really is. And funnily enough, Professor Levin wasn't the only astrophysicist I spoke to who made this point about a species damning itself to extinction. Here's our Nobel Prize-winning Professor Queloz again.
And we are facing, in terms of species right now, an interesting debate because we have enough nuclear weapons on Earth to destroy ourselves entirely, and that would be very quick and very easy to do. And we are, in a way, terraforming entirely the Earth, changing the temperature, changing everything. And there's a point when you change too much, you cannot go back, and it means the end of the life on Earth.
And there's a point when you change too much, you cannot go back, and it means the end of life on Earth. Well, that's a really stark warning, isn't it? We'll face the same fate, is what is being said, as the dinosaurs.
And worse, because we'll have done it to ourselves.
So the question of are we alone in the universe has very quickly descended into will we survive long enough to find out?
I mean, you've hit the nail on the head there, Stephen. This question is not so much about the universe as it is about our relationship to the planet. And it ties into all the big questions about what it means to be a member of humanity. I think it's a great question.
And so do I. It's also rather hard to answer, which is what I suppose gets all of the scientists excited. Perhaps, I don't know, Mhairi, you think humanity's greatest challenge?
Yeah, incidentally, it's also been my greatest challenge trying to find an answer for you today. Do you think it's changed the way you see our universe and the potential worlds beyond ours?
Well, what I am very clear about is the level of expertise that we've had on the podcast and the people you've talked to, including that Nobel Prize winner. I think this question changes how we treat each other too. If you imagine the politics and the arguments that exist on the planet and then zoom out and look at Earth as one of hundreds of billions of planets in the billions of solar systems, then the pale blue dot, as Carl Sagan called it, well, it all seems quite irrelevant.
Yeah, I think it's impossible not to speak almost poetically about life in the universe. At the beginning of this podcast, I mentioned that Arthur C. Clarke quote about two possibilities existing, that we are either alone or we aren't, and both being equally as terrifying. And I put this to Professor Levin, who we heard from many times already, but she explained why she really has no fear about failing to make contact with extraterrestrial life.
Imagine you are shipwrecked on an island. There would be a sense in which you felt alone, but you would also know that you were not literally alone in the entire universe, that there was humanity out there, and that you were in some sense connected to that humanity from your origins with this whole species. And that's how I see life around exoplanets. I imagine there is life out there. I can't believe that there isn't. It would be absurd. It would be impossible. Nature is just too inventive. The question is are we all marooned on our islands and throwing messages in a bottle out into space? And that is ultimately, I think, probably a pretty pervasive attitude among a lot of scientists. I hope more just to find out, yes, there are other life forms out there than I do that I will receive a message in a bottle.
Isn't that beautiful? I mean, at one point in the interview, she described us as progeny of the universe, which is how I will be referring to myself from now on.
And quite right, you are the progeny of the universe. And if you are the progeny of the universe, I'm the man of the world. Although I'd like to think of myself really as a child of the sun, given half the chance. So, but it comes at I'm diverting away now from that key question about are we alone in the universe? The Answers Project concludes, we don't know yet.
No, we don't know. What we do know is the universe gives intelligent life a very large number of chances, though. We also know that there's only a small probability of going from a chance at life to a spacefaring, technologically advanced civilization.
And also, we have to look after our life on Earth.
Yes.
Hence the climate change argument and the biodiversity arguments. But what I still find strange is that with trillions of planets out there, none have found a way of communicating with us. Or perhaps they have, and we haven't been told. I doubt that, because nobody keeps a secret these days, certainly with social media. But I'll save that for another show. Perhaps, what do you think, Mhairi, a conspiracy show? Mm-hmm. But the bottom line is we need more data. And you never heard me say that before. And no amount of speculation will substitute for that information. We simply have to find out to know for sure.
And in the meantime, try not to wipe ourselves out with nuclear weapons.
Or start burning down more forests. Fingers crossed for both. Thanks very much, Mhairi. That is really a fascinating podcast. We're hoping you, our audience, will get in touch with us to tell us what you think. Do you think there is intelligent life out in the universe, not on planet Earth? Do you think there is intelligent life in this podcast? I think there is, lots of it. Let us know. And if you have a question you'd like answered, we'd love to get the bottom of it in the next episode, in the next series of the Answers Project. Find us on CGTN Europe's Facebook or Twitter page. You can also subscribe to this podcast on iTunes, Stitcher or Spotify. From down here on Earth, thanks for listening.
Goodbye.
Goodbye.